Hello folks, welcome to API Test Automation with Rest Assured tutorial. I am Faisal Khatri. In the previous video, we discussed how to use JSON file as a request body to test post APIs. In this video, we'll learn what is Builder Design Pattern, what is Datafaker, benefits of using Builder Design Pattern with Datafaker, and how to create a request body using the Builder Pattern and Datafaker for testing post API request. Let's first start understanding what Builder Design Pattern is. The Builder Design Pattern is a creational design pattern that allows constructing complex objects step by step, allowing different representations of the same object. It separates the business creation logic from its structure, making the code more readable and maintainable. This pattern is especially useful when dealing with objects that have many optional parameters, as it avoids messy constructors and improves test data creation. What is Datafaker? Datafaker is a library that generates realistic looking fake data such as names, emails and addresses, numbers and more. It is commonly used in testing to avoid hard-coded values and to simulate real-world data scenarios. Benefits of using Builder Design Pattern with Datafaker. The most important benefit is that it generates dynamic data at runtime, allowing random and fresh test data generation every time the tests are executed. It provides a faster test setup as there are no input-output operations involved in searching, locating, and reading files, external files such as JSON, CSV, Excel, and so on. It can easily handle parallel test execution as there is no conflict of test data between concurrent tests. It helps in easy maintenance as there is no need for manual updating of the test data. With these benefits, let's move on and understand how we can use Builder Design Pattern with Datafaker and implement it to write post API request. The first step is to generate a POJO for the request body. But before that, we need to update some of the dependencies in the pom.xml. I have already added the dependencies for the Datafaker and Lombok libraries in the pom.xml. Please check out my earlier video on project setup if you need more details on how to set up the dependencies in pom.xml. The link to the video is provided in the comments. Let's now begin with the first step that generates a POJO for the request body. As discussed in the earlier video also, we will be using this post add order endpoint for demonstrating the post API request testing. This is a part of the RESTful e-commerce application that is available on GitHub for free and can be used for practicing test automation for the APIs. You can check out my earlier video on the project setup and installation. I have provided the different ways where we can use to install and run this application on your local machine. This post add order API uses the request body in the form of JSON array, which can hold multiple objects for the order details. This way we can add multiple orders using a single request body that contains a JSON array. Let's create a new Java class for POJO and name it as order data, since we will be using this POJO for holding the order data objects. We will use Lombok in this POJO as it helps in reducing boilerplate code such as getters, setters, and builders. By using annotations like getters, @getter, @setter, @builder, the class can be made concise, readable, and easier to maintain. The field name for the JSON request body has a underscore in between. You can see user underscore ID, product underscore ID. But as per the Java standard conventions, we follow the camel case pattern. So we write it as user ID. The I is in caps. There is a issue here, like we need the object name to have an underscore in between, like user underscore ID. But while writing the POJO, we write it in camel case. To mitigate this issue, we can make use of the @JSON property annotation that is provided by the Jackson databind library and provide the actual field name in the annotation over the respective Java variable name. So for this user ID, we will be mapping it to the user underscore ID field name. This way we can do it for the other fields in the order data object. The order of the JSON fields can be preserved by using @JSON property order, where we can put on the field names that we want in the particular order. The order of the JSON fields can be preserved by using @JSON property order annotation and passing on the fields in the order in which we want them to appear in the API request. But if we do not pass on this @JSON property order annotation, then Java will automatically put on the fields randomly based upon the values that are generated on runtime. So we might get the product name appearing first, then the product ID, user ID, the total amount coming in the top, and then text amount, quantity. The order will be in the jumbled order. So to preserve the order, we are using this @JSON property order annotation. This completes our POJO part. The next step is to create a builder class for generating data at runtime with Datafaker. In this step, we will create a new Java class, order data builder, for generating test data at runtime using the Datafaker library. I have created a static method getOrderData inside this class that implements the Datafaker library and builds the order data for generating the request body in JSON format at runtime. The Faker class is instantiated first. It provides various methods to generate the required data such as names, numbers, company names, product names, addresses, etc. at runtime. You can see the fake product number is generated for the product amount and the quantity fields. But for the gross amount, tax amount, and total amount, the value is calculated as per the required formula. So the gross amount comes by multiplying quantity into product amount. Tax amount comes by multiplying the gross amount into 10% of whatever amount we have, gross amount. And then gross amount plus tax amount equals to the total amount. This way, our test data for the respective fields for product amount, quantity, gross amount, tax amount, and total amount are generated at runtime. Using the order POJO, we can populate the required fields using Java's builder design pattern. Since we have already applied @builder annotation from Lombok on the order data class, you can see in the order data class, we have already applied @builder annotation of Lombok library. This can be used to generate the required fields through Java's builder design pattern. It enables this builder annotation enables an easy and clean way to construct order data objects. Finally, we will use this order data dot builder and then the field names on which we want to supply the required values. So this user ID, we will supply a random field value of number between 301 and 499. Product ID, similarly, we will supply a value between 201 and 533. Product name, we have already defined it at the top where we will be supplying the values. Then product amount, whatever value we have calculated, tax amount, total amount, those values will be supplied. And at the end, we need to supply this dot build method. The getOrderData method returns an order data object populated with randomly generated test data using Datafaker library. This completes the order data builder step where the test data will be generated randomly at runtime. In the step 3, we will write the post API request test where we will be supplying the test data using the order data builder class that we generated in the previous step. The request body requires the data to be sent in the JSON array with multiple JSON objects. The order data builder class that we generated in the previous step will generate the JSON objects, but we need to supply the JSON array in the request body. That JSON array can be handled in the test itself. So this line of code, list order data list equal to new array list, and then a loop that is running for 4 times. This is a hard-coded 4 here, but can be increased to 5, 10, 15, whatever times you want, whatever data objects, order data objects that you want to generate. Since it is a demo, I have generated 4 order here. So this code will generate the unique order records using getOrderData method and add them to a list named order data list. Once the loop completes, the list holds 4 unique order data objects, each representing a new order ready to be included in the test request. And this particular order object will be sent to the request body here. The rest of the code that is used for sending the post API request remains the same as we have discussed in the earlier part of the videos as well. Once the request is sent, it will check that the status code 201 is returned in the response, and it asserts that the body has a message field that contains the text orders added successfully. This is the initial part of the verification, just to verify that the post API request was sent successfully. Performing the assertions with builder pattern. When the request body and its data are generated dynamically, a common question arises. Can we perform assertions with this dynamically created data? The answer is yes. In fact, it is much easier and quicker to perform the assertions with the request data generated using the builder pattern and the Datafaker library. We will perform some assertions here. So we have already written the code here, assert that body. Inside that, there is some JSON path and there is an equal to statement. Similarly, there is another JSON path which checks for another assertion and expected statement. So the order array in the response holds all the data related to the orders. Using the JSON path, orders of one.userid, the user ID of the second order will be retrieved. You can note here that the array index starts at 0. So the second order appears in the first object in the response. Similarly, the total amount from the fourth order can be fetched using the JSON path orders of 3 dot total amount, and using the hemcrest equal to method, we can verify like order data list dot get first, that is get the second order. One refers to the second order, and get the user ID that we passed. Similarly, we can pass on the same object order data list dot get 3, which is referring to the fourth object in the response, and get the total amount. The builder design pattern comes in handy for comparing the expected values, where we can use the code order data list dot get 1 dot get user ID to get the dynamic value of the user ID from the second order, and order data list dot get 3 dot get total amount to get the total amount of the fourth order. So let's quickly run this code and check out the output. And we can see in the request body, it was passed as a JSON array. And since we ran the loop for 4 times for generating the order data objects, 4 different objects, you should see 4 objects generated here. This is first, second, third, and fourth. And each object has a field that is required for the order object and with some realistic value, but that is a fake value that is generated using builder design pattern and Datafaker library. The request was sent successfully. We can see the status code 201 coming up successfully. In the response, we can see the message field has a value ordered added successfully. In the orders array, we can see the objects having the values correctly as generated and sent in the request. There should be 4 orders and those are correctly displayed. The test passed successfully. That means the assertions also passed as required, as expected. So as per these assertions, let's quickly manually verify if the assertion is working as expected or not. In the second order, the random value for user ID was generated as 379. Let's quickly check out the response. In the second order, we can see the user ID is 379. So the first assertion passed successfully with the dynamic user ID values that was generated at runtime. Similarly, let's check for the total amount. In the last order, the fourth order, the total amount is 53. And in the response, we can see the total amount appearing as 53. That means these assertions that were performed for the dynamic data passed correctly as expected. Based on my experience, using the builder design pattern in Java provides several advantages over the other approaches for creating request bodies. It allows dynamic values to be easily generated and asserted, making test verification and validation more efficient and reliable. That's all for this video. Let me know your feedback in the comments. In the next video, we'll learn how to write GET API test with REST Assured. Thanks for watching.